can hear me over the noise around here, try to speak as loud as I can. My name is Brian Dempsey. I'm a lecturer in Waterford Institute of Technology. This is my colleague, Gordon Chisholm. Gordon is also a lecturer in Waterford. What we want to talk about today, I suppose a lot of it is experience that we're having on our architectural and BIM technology program, but also what we're experiencing through BIM Collective Research Group, where we research BIM technologies and the application of those BIM technologies to small to medium enterprises. What we learn in that we bring back to the undergraduate course, and we see this in the positive cycle. So what we want to concentrate on, there's quite a few talks today on BIM, and an awful lot is going to be on the documentation of PAS 1192 and so on. So we're taking a slightly different view on it today and looking at it more from the point of view of BIM visualization. So how do you interact with a model? Yes, we've got the data, yes, we've got all these different things, but the BIM process is so immense. We've got to choose one small part of it for a 15-minute talk. So looking at these images here, and the next slide as well, these documents were actually tender documents back in the day. The information that we now need to produce in our documents is so much more advanced than what it used to be. These were perfectly adequate to build these buildings. And as we know, these buildings have been around for a very long time and have maintained in such an exceptional state. But we do things differently now. So we need to move on. From the way we had worked, we're moving into working in a very different way. Move on there, Gordon. We're very much in a digital era. I don't know if you've seen this slide before, but does anybody recognize what it is? Or to give a guess of what it might be? The top one was the Pope being elected in 2005. 2013, when Pope Francis was elected, this was the difference. So, I don't know how many smartphones you can see in 2005 compared to 2013. We interact with each other differently, and we also, I suppose it's just by default, we interact with buildings differently. So if BIM is about communication, this is how we communicate now. We don't write notes to each other very much anymore. We communicate electronically. So 2D is 2D, too dim for modern technology, for a technologically advanced era. Let's find out. So we're working in disconnected silos. We've got, that leads to certain problems. Working in disconnected silos. So we've got a number of, that leads to mistakes in how we communicate ideas. And again, it's through our communication of ideas. If we can communicate effectively, you see less of this. Illusion clouds shouldn't look like that in reality. So the building industry is the only major industry that delivers its product to the market without first thoroughly testing it. First time we find problems is on site when we put up the thing, suddenly there's a beam in the way. Yeah, okay, maybe we should have spotted that, somebody didn't, so now we've got to fix it and we've got the incurred cost. So maybe we can do that a little bit better. But it's not just about what we see. BIM isn't just about visualization. I know the topic I'm talking about today is how we visualize it, but the eye in BIM, again, it's all about the information. So it's the data that's held within it, the metadata, that's the component data which describes the data about data. So it's that inherent quality of the BIM model that shows us what we need to do. So what is BIM? It describes an activity, it's not an object. To describe the result of modeling activity, we use the term building information model, or simply a building model. So it's not about the model per se, it's about what you do with the model. It's not a file format, it's not a software application, it's not an information technology. It is a business model defined by workflows, and it's enabled by information technology. So the output from this, yes, we can produce our sheets. We still need to be able to produce our data, 2D. Yes, the 2D images are still there. We still need to produce them. These are just some examples of work produced by a third-year student in our Architecture and BIM Technology program in WAT. And so we get our visualization, but we need to go beyond that. We've been able to do this for a long time. You know, 3D Max, 3D Viz, whatever software program you've been using, we've been doing this for a terribly long time. But how do we now integrate or interact in a more efficient way with our model? This is a project that we worked on in Boston. This is a project that we're working on in WAT with Bosch and Ron, where they were doing a major expansion of their building. So we're using our drone technology, we're flying over their building twice a week, providing them with more information. Then we're able to take that data using Match Mover, we're able to match the path of the camera, and then we're able to link, so we've got all these little blue points or data points that we're able to link from the drone data, we're able to link that back into our BIM model, and then we're able to link in the BIM model to it. So we're able to simulate what's actually happening, what's going to happen, but it's all matching it back to the reality on site. So this is part of our drone team that we're working on it, members of Bosch and Ron. This is also another sample of building that we worked on in WAT. So this is using photogrammetry to survey a historical building. It would take you, I don't know how long and how inaccurate it might be to use measuring tape to survey that building. Using the drone, we were able to use photogrammetry to take it in. Yes, as you can see from the model, it needed some tweaks. That portico is not actually a Gaudi building, so it needed to be tweaked when we got it back in, but 90% of the data was captured using the drone data. And then we're able to use that, taking our aerial footage, taking it back to a 3D mesh, into textured meshes, rectified surface meshes, and then into a 3D point cloud. That then can be brought back into Revit, and we've got an active model. This is a project that we did. It was actually a partnership project with Erin O'Leary. Again, this was done by the students of the Architecture and BIM Technology program, where we were to reimagine the Waterford train station. So this is, for those of you not familiar with Waterford, this is the Waterford city centre, this is the Waterford train station. As you can see, the train station is in the wrong place, it's on the wrong side of the bridge. So we did a project just to reinvent the train station. But one of the things that we find when you try to get a new project going, it's how to interact, how to get that idea across to the public. So by being able to invite the public to visualize your project in a more efficient way, it helps with social interaction and it helps with getting the project through. So this was just the working through of the building. The reason I put up the sketches, we're not suggesting that we throw out the sketchbook. The initial sketches, yes, they need to stay. You need the idea, the hand-eye coordination is still a wonderful thing to get the ball rolling, but what you do with that afterwards. So there's the precedent, the sketches, and that brings it on into the imagine or what the design of the building is going to be. So this is more about how we're going to communicate this idea. Don't think we've got the sound, but this basically, again, it was a video done by the students, linking it back into InfraWorks. So in showing the building, yeah, there's usually the EastEnders music over this. Anyway, we don't have sound today. So again, showing student work, it's a year 4 student work, showing how the building might interact with where it goes. But we did a workshop where we invited the public in, and we set up a number of different stations. So started off with 2D drawings, plans, elevations, and sections, and asked the public, people who are not used to looking at drawings, how did they feel about this? What was their level of understanding? And then we brought them down through, showed them a point cloud, we showed them the walkthroughs. That InfraWorks model was actually an interactive model where they could work through it. The final station was where we brought this into VR. We brought this into an Oculus, onto the Oculus Rift through Unity. And this is one of our students showing one of the Erin O'Leary directors around their building. We found that the public understanding of what it was so much more. At least the feedback they gave us was so much better through the three-dimensional interaction. And going on into the VR world, it just made it so much easier for them to understand. So this is looking at some of our VR environments. Ivan Sutherland he's regarded as being the godfather of VR. This is a quote from 1965. So the ultimate display world would of course be a room in which a computer can control the existence of matter. A chair displayed in such a room would be good enough to sit in. Handcuffs displayed in such a room would be confining, and a bullet would be fatal. With appropriate performing, such a display would literally be the wonderland that Alice walked. So, from 1965, I mean, what a vision to be able to see where he was going. And this is the sword of Damocles was held as being the first head-mounted VR set. So if we just look at this video, this is something that we're working on, is integrating our model, but being able to simulate. This is looking at it in a very basic manufacturing scenario. You'll notice that there's a few clashes as this goes on, but it's creating the idea here is that we can look at a manufacturing system, but you don't have to shut down the line in order to work it through. So you can see here that from these slides, there were clashes, but this is a good way of testing how you work out your clashes. Another thing that we found here is when you can now bring in the people who are working on this floor, rather than just showing drawings, you can bring them in, put on a VR headset, show them what's going on. And in one case, we showed somebody and he was looking around and he was saying, yeah, that's all well and good, but where's my pallet? I always keep a pallet there, and that's where I take my raw materials. So in the design, that wasn't considered. And so this design could have pushed on, it would have arrived, and then this guy would have gone to start work and say, but this won't work, I haven't got my pallet. And then that pallet happened to be in the middle of a fire escape. So it allows people to have a greater understanding of their environment in a way that they can understand it. So then this is, again, just looking at bringing on the asset information model into interactive. This is, again, a beta software that Autodesk is producing at the minute. But you'll notice that you can go in and walk around the machine, or the environment. You can select items within the environment, and in the virtual reality, the data associated with those can all be brought up. It can be interrogated, it can be commented upon as you're walking through the building. So it's not, we want to go beyond the idea that we can look at a nice pretty picture and say, oh, that's wonderful. Even with VR, we can go in and we can walk around and say, yeah, that's great, we can see what's going on. But now we can go in and touch things, we can get the properties of that, we can comment on the properties of that, and give feedback on it. So this is one of the processes that we're working on at the minute. So taking our Revit models, taking that into Max, into Unity. Autodesk are developing on quite aggressively in this space as well. But taking that back into the Oculus Rift and being able to have a proper understanding and experience of the building. I suppose augmented reality is maybe the next step. It is here to a large extent, but we're still, to the point where we can actually see what will be when we look at what is. Just quickly to a little bit more about our research group. We're in stand number 8 if you want to come over and see us. We've got the headsets and all the toys over there if you want to come over and have a play. Sometimes BIM is just taken far too seriously. It's nice to be able to stop and have a play around with some toys now and then, that you can get to enjoy it. A lot of what we do in the research group is, that's just some of the people that are involved in the research group with us. And we use an awful lot, we work very much with Enterprise Ireland on innovation vouchers. It's a very effective way for small to medium enterprises to get involved with BIM or with specific areas where we can, on a temporary basis at least, become your research and development arm. So please come and talk to us. We're going to be over at stand 8 again, and we'd love to talk to you and show you some of the toys that we're working with. And perhaps if you're interested in looking at an innovation voucher with us, we'd love to talk to you about that. Here's just some of the companies that we've worked with through our innovation vouchers, and so far so good. Thank you very much.